Dear student, today we are going to look at probability, and we are going to look at a case of first picking a box, then we pick a sweet. 2. We are going to look at a scenario of picking without replacement. 3. We are going to look at a case of forming a distribution. 4. We are going to look at a case of calculating the mean from a given distribution. Question: boxes A contains 4 red sweets and 3 green sweets. Box B contains 5 red sweets and 6 green sweets. Box A is twice as likely to be picked as box B. Box A is twice as likely to be picked as box B. If a box is chosen at random and 2 sweets are removed from it, one at a time without replacement. I repeat, if a box is chosen at random and 2 sweets are removed from it, one at a time without replacement. Part A. Find the probability that the 2 sweets removed are of the same color. Part B, Roman numeral 1. Construct a probability distribution table for the number of red sweets removed. Roman numeral 2. Find the mean number of red sweets removed. As part of the solution, we have to first model the question. Remember, they told us that we are going to pick 2 boxes. Then, among those 2 boxes picked, we are going to choose a red ball and a green ball. As we see, we have boxes A and B. Box A has 4 red and 3 green sweets. If we total up the number of sweets in box A, they give us 7. Box B contains 5 red and 6 green sweets. Remember also, the question said the probability of picking box A is twice the probability of picking box B. That one will lead us to equation 1. No, from probability theorem or from probability theory, the total probability is always 1. What does that mean? The probability of picking box A plus the probability of picking box B, we shall get a 1, and that one will take us to equation 2. From there, we are going to put equation 1 into equation 2. That one will mean that we have 2 probability of B plus probability of B is 1. After solving mathematically, the probability of picking box B is a third, and the probability of picking box A, it is 2 out of 3. Now we are going to generate our probability tree diagram from the table we've drawn up there. Remember, we have to first pick a bag. We pick a first sweet and we pick a second sweet, as you see on the screen. We've known the probability of picking bag A and the probability of picking bag B. We can first pick bag A, then from that first bag A, we pick a red sweet and a green sweet. We can either pick a box B, we pick a green sweet and a red sweet. That is the first ready, that's the first sweet to be picked. 2, we can proceed by picking a sweet from the preceding sweets. Look at the probability tree diagram and see whether what we've done is right. Now, the reason why we draw a probability tree diagram is to generate a sample space. Remember, a sample space is where we can obtain the scenarios to be tasked. The sample space we've generated, it's there. We can have the case of picking box A red sweet first, a second greens. Type O, we have the probability of picking box A red sweet for the first time, then a red sweet for the second time, up to when we get a probability of picking bag B times the probability of picking a green sweet for the first time times the probability of picking a green sweet for the second time. Students, here I move at a high speed, reason being we have to save some time, but if you see that I'm rushing, you can pause the video, you see whether every information on the page is right, because it's upon understanding, not upon watching. Now, from our sample space, they've tasked us to find the probability of picking 2 sweets of the same color. Now, if they tell us to pick the 2 sweets of the same color, this is what we have to do. We have to pick a bag, then we pick a sweet, we check, we pick another sweet, we check. Now, for the same color, we picked a bag A, then we picked the first sweet, it was green. Then for the second time we picked a sweet, it was green. Therefore, first green, second green, it is of the same color. Oh, we picked bag A, we picked the first sweet, it was red, and the second it was red. Or we can pick bag B, we check, the first sweet is red, the second sweet is red. Or we can pick bag B, the first sweet is green and the second sweet is green. Remember the and or situation. If we see O, then we are going to add. The reason why we are multiplying probabilities, for example, probability of A times the probability of green sweet 1 times the probability of the second green sweet, it's because the chances of picking box A, it is independent of picking a first green sweet, and the probability of picking a first green sweet is independent of picking a second green sweet. Reason being, you first pick a box A, you pick a green sweet for the first time, then a green sweet for the second time. Therefore, they are totally independent. That's why we do multiply. And we shall substitute in the values. After substituting in the values, we add. The answer obtained is 0.44, which is to 2 decimal points. Part B, Roman numeral 1. Remember, they've told us to form a distribution. Therefore, we shall say, if X represents the number of red sweets, then for picking without a red sweet, X is equal to 0. Remember, we can pick a bag or a box, and then we look at a sweet picked when it's not red, then we pick a second sweet when it's also not red. Therefore, P of X is equal to X, where X is 0, is equal to, we can pick a bag A, we pick a green sweet for the first time, and a green sweet for the second time. Or we can pick box B, we pick a green sweet for the first time, and then we pick a green sweet for the second time. That one will mean that the two sweets removed are not red. We shall calculate its probability, which is 0.1922 decimal places. For picking without a pair of sweets, for picking with a pair of sweets containing only one red sweet. For example, we can pick sweets, then the two sweets removed, or the pair of sweets removed, we see that there is only one red and one green. Therefore, that one means that our x will be a 1, or one red sweet. And the probability of picking one red sweet is the same as saying the probability of picking box A times the probability of picking red sweet for the first time times the probability of picking a green sweet for the second time. Or the probability of picking box A times the probability of picking a green sweet for the first time times the probability of picking a red sweet for the second time. Or the probability of picking bag B or box B times the probability of picking a red sweet times the probability of picking a green sweet. Or the probability of picking a box B times the probability of picking a green sweet for the first time times the probability of picking a red sweet for the second time. Now students, if we look at the sample points, we see that we are having a box, one red sweet, one green sweet. So that one means that we have only one red sweets. We shall substitute in the numerical values from our tree diagrams generated, and the answer we shall get 0.56 to 2 decimal points. Good. For picking with a pair of only two red sweets, what does that mean? We are going to pick the sweets, but the two sweets removed, they will be of red only, and x will be two red sweets. And the probability of getting the two sweets when they are red is the probability of picking box A times the probability of picking a red sweet times the probability of picking a red sweet for the second time. Or we can pick bag B. We pick the first sweet when it is red and the second sweet when it's red. So that one means that the two sweets removed, they will be of red color. We shall put in the numerical values, which is 2 out of 3 times 4 out of 7 times 3 out of 6 plus a third times 5 out of 11 times 4 out of 10. We shall calculate and we shall get the answer as 0.2522 decimal points. From there, now we have the x and the corresponding probabilities. If we do that one, then it means that we are going to create, or we are going to form a probability distribution table. How x's, or the number of red sweets, are distributed with their probabilities. Table of distribution. We have x, the number of red sweets, and the expected probabilities, or the probabilities of picking those sweets. For example, for picking without a red sweet, or x is 0, the corresponding probability is 0.19. To pick one sweet is 0.56. To pick two sweets, it is 0.25. But students, it's not always true that each table we draw will be a proper distribution table. It is not sufficient to conclude that the above table is a good distribution unless we prove its probabilistic properties. What are those probabilistic properties? What are those probability properties? 1. Non-negative probabilities. You must ensure that the probabilities in your probability distribution table are not negative. I.e., look at our table. When x is 0, the probability is 0.19. Therefore, it is positive. When x is 1, the probability is 0.56. It is positive. When x is 2, the probability is 0.25. Therefore, non-negativity probability theorem, it is fulfilled. 2. The total probability should be 1. Let us see. Get 0.19, add 0.56, add 0.25. Are you getting a 1? Yes, we are having a 1. And if we have 1, we shall say that the above table satisfies the two probabilistic properties. And since it suits the probabilistic properties, we can go to Roman numeral 2, where they want us to calculate the mean number of red sweets. Don't forget that to get the mean, it is always summation of all x. Capital X times the probability of capital X is equal to x. We shall get x when is 0 times its corresponding probability, which is 0.19, plus x when is 1 and the corresponding probability is 0.56, plus when x is 2, the probability is 0.25, and we shall get the value when is 1.06 to 2 decimal points. But student, don't forget that sweets are realistic. Sweets are realistic, and at this time you can be chewing your sweet. There is no a half sweet unless we cut them. So we shall conclude that hence the mean sweet is 1. Thank you for watching. If you see that there is something you've not understood, there is something you want to add, you can contact the phone numbers on the screen, or even you can WhatsApp me. I remain Teacher Sekate Brian. Thank you.